So, hey, hello everyone, my future engineers. I hope you all are well. And in today's video, in our crash course, we are going to completely for laws of motion. And I'll not be teaching the friction chapter here. I'll be taking that friction topic later on. In this video, I'll be only doing the numericals related to the frictionless surface. Okay. So basically, in this video, I'll be mainly focusing on the basics of laws of motion. I'll teach you that what are the laws of motion, and basically there are only 3 laws of motion. This is the first thing what I'll be doing in this video. And the next very important thing is how we are going to apply the laws of motion, because I already told you that in physics, if we read the syllabus or if we focus on the topic which are there in our syllabus of JEE 2025, you will be finding a very limited number of topics, right? But if you see, the number of questions which might be asked from those topics are unlimited. So it's not going to be in that way that we will be solving each and every questions. We have to develop the mindset. We have to develop the approach which will help you to solve any type of questions, right? So my main focus will be to get you the main approach that you can use in multiple questions, right? So that is my approach going to be here in this video. I hope that my audio and video is clear to everyone, right? So let me start this lecture. So let's begin this lecture. So first and foremost, this lecture is dedicated to the great scientist Newton, because he was one of the best observer I have ever experienced. And this is because of Newton we are studying this chapter, right? So Newton told us that when you are observing any kind of motion, there are some patterns, and he ultimately gave us the laws according to which every motion is happening. But there are certain conditions which must be applied, that all Newton's laws of motion are only applicable in the inertial frame. What is the inertial frame? Inertial frame is basically a frame where the acceleration is 0. Okay, we will I'll show you that from the question part. But let's start this chapter with the very first law, which is known as law of inertia as well. So this law states that if net force on any body or an at any point is 0, then I can say that acceleration is also 0 at that point. And you know what? The vice versa is also true for this. If I'll go for the vice versa of the same statement which I am putting here, if acceleration is 0, then I can definitely say the net force acting on the body is 0. And you might have learned another statement. This statement is very important when we are solving the numericals. And as you know that for the JEE exam, the most important thing is that you must be able to apply all the concept which you are studying, right? In your previous classes, you might have studied another statement which states that a body continues to be in state of motion in a straight line or at rest unless compelled by an unbalanced force, right? This may be the statement which you have studied in your previous classes. But for us in JEE exam, I'll be more focusing on this terminologies, that if F net is 0, then acceleration is 0. If there is some acceleration on the body, that means there is some force acting on the body, right? So let me explain you. Assuming that a person is standing in a bus and there is a floor, person feet is touching the floor. The train starts moving. When the train starts moving, the person's lower part comes in motion. The person lower parts comes in motion, right? Because the floor gets started moving, and this person's lower part is attached with the floor, right? So this part starts moving. but there is no force acting on the upper part. This upper part wants to be in rest. Because of that, it might happen that when the bus starts, the person may lean backward, right? And to avoid that situation, he always have to hold something. Is this thing clear? Same situation can happen here. I have taken a cartoon here. This cartoon is moving with a constant velocity, and suddenly there is an obstacle out there. And when this cartoon reaches at this point, what will happen is lower part will comes to rest, but his upper part is in motion. Because of that, he will fall forward, right? This is known as law of inertia. Let us understand what does this first law says, and this is the concise map for the first law of motion. This first law says that any change, if you want to change any state, if I'm saying the state, there are three states: state of rest, state of motion, inertia, or you can say inertia, inertia of rest, inertia of motion, inertia of direction. So any change requires some force. If force is not acting, there will be no change in the acceleration. This is what we are going to learn in this Newton's first law of motion, right? So it's my old statement that either train insane or remain the same. If you want to excel in your life, you have to apply or take massive action. If you're not taking the actions, you won't excel, right? So basically, if there might be some conceptual question, and in those conceptual questions, there are two situations in which you have to think that Newton's first law is applicable there when the object is just starting or when the object is stopping, right? Then you can apply the Newton's first law. Let's solve some questions related to this. This is a question from the NCERT book, and you might have like if you are solving the previous year as well, so you might have got this question in your MCQs. So hello Moms Grace, what's your real name and where are you from? Please do let me know in the chat, and please mark your attendance in the chat. So according to this example 3.1, an astronaut accidentally gets separated out of his small spaceship. Why there is a special word small being used here to show that the spaceship is very small as compared to the other ships and as compared to the astronauts we have. So that means I can ignore the mass of the spaceship. I can ignore the mass of the spaceship, and there is an astronaut. There is an astronaut, and when he comes out of the spaceship, we have to find out that what is the acceleration of the astronaut. This is what we have to find out, and the acceleration of the spaceship is already given to us, that it's 100 meter per second square. Accelerating in the interstellar space, you know what is the interstellar space? Interstellar space is basically a actual space where when basically this is the space between the two galaxies. So when the astronaut comes out of the spaceship, there is no star nearby, there is no planets, there is no moon out there. So that means there is nothing out there. It's a complete space. So what will happen to that? We know if nothing is attracting this object, then I could say that the net force acting on this is zero. And if net force is zero, I would definitely say that acceleration will also be zero. This is basically the acceleration of the astronaut once he comes out of the spaceship. But the velocity, we cannot comment on the velocity, that what is the velocity of the astronaut. Velocity is not 0 here, because earlier this spaceship is having an acceleration, so this astronaut may be moving with certain velocity, but his acceleration will be 0. So what does it mean? It means that this astronaut is moving with a fixed velocity, and that velocity will not get changed. Similarly, a new pattern of questions might be asked in your exam, because I have seen that NTA has asked this question in the NEET exam. So you know what? If that question being asked in the NEET exam, it might come in your JEE exam as well. So another pattern which might come, assume that now this time there are two astronauts. Another pattern. Now assume that there are two astronauts. And if there are two astronauts, then what will happen? The mass of astronaut is this, mass of astronaut is this. When there are two astronauts, both of them will attract towards each other. Why? Because we know that due to the force of gravity, due to the gravitational force, which is equals to g m1 m2 divided by r square, they both attract each other, right? So this will be going to this side and this will be going to this side. So this might be there in your exam as well. Hello, good evening, Ajay. Mom's Grace, what's your real name? I have asked you, and where are you from? So please do mark your attendance. Here, another question. This question is from JEE PYQs. And in this question, we have multiple correct answers. Please read the question and give me the answer in the chat. Here, in this question, we have been provided that a reference frame attached to the Earth. A reference frame is attached to the Earth when a viewer is in the space. There are multiple ways to solve any questions, but the easiest way is to just imagine an example which you may have studied, or an example which is relevant to the question. And the another thing is that assuming the values. So these are the two methods which I'll be using multiple times whenever I am solving the question. So according to this, I have one example in my mind to show you. I'll be considering that there is an Earth and we have a moon. In space, there is a moon and your observer is standing on the moon, right? Viewer is in the space. I'm considering that the viewer is on our natural satellite, and here we are having the Earth. And you know what? We have sun also, and the Earth is revolving and rotating, right? So now just read all the options given here, and you have to tell me that what could be the answer. And here we have multiple correct answers, so remember that thing also. So the first statement says that a reference frame attached to the Earth. That means our frame of reference is here, x, y, z. Our frame of reference is here, and we have to find out, is an inertial frame by definition. Is it? No. Why? Because according to the inertial frame, we must have the acceleration as 0. According to the inertial frame, we must have acceleration to be 0. So is an inertial frame by definition? No. Cannot be an inertial frame, because cannot be an inertial frame. Yes, if I'm telling that it's not an inertial frame, that means that it can't be an inertial frame. Why? Because Earth is revolving around the sun. So Earth is revolving around the sun. Yes, it's true. So Earth is basically revolving. That's why I can't say. And when Earth is revolving around the sun, at every point, I would be saying that Earth is changing the direction. And when Earth is changing the direction, that means the acceleration will be different. So when our acceleration is different of our frame of reference, I can't take this condition, because for being an inertial frame, we must have to take that the acceleration must be 0, right? So this option B is correct. Now, if we goes to the option C, is an inertial frame. No, it can't be an inertial frame. They are saying that because Newton's laws are applicable in this frame. No, you cannot apply Newton's laws in non-inertial frame. We can only apply Newton's laws in inertial frame, right? Next statement, cannot be an inertial frame. Yes, because Earth is rotating. Earth is rotating about its axis. So Earth is rotating about its axis. This statement is also correct. So our answer for this question is B and D. So option B and D is correct. I hope that this solution is clear to you. Hi, future IIT and vlogs. Kupuswamy PKS. Hi. Kupuswamy PKS. Where are you from? Ajay, where are you from? Future IIT and vlogs. I think that you were there in my previous class as well. Next, let's solve this question. This question is also from JEE PYQs. You have to neglect the effect of rotation now. Do not consider the rotation effect of the Earth. Suppose the Earth suddenly stops attracting. Earth ignores that I do not be applying the gravitational force to you. I do not want to be attracted or attracting you. So suppose the Earth stops suddenly attracting object placed near its surface. A person standing on the surface. A person standing on the surface of the Earth will. What will happen to the person? Now, do let me know that what will happen to the person. There is a Earth. This is the radius of the Earth, and we have one person here. Imagine that this is you. Imagine that this is you. Earth is not attracting now. What will happen? If Earth is not attracting, there will be no weight of the person, right? If Earth is not attracting, I would be saying that the acceleration due to gravity is 0. Your weight will be 0. But this, we have to look out in the option. In the option, it is saying that the person will fly up. No. Why? To fly up, there must be some force, right? If there is no force acting on the person because gravity is not there, I would be saying that net force on the person will be 0. And if the net force on the person is 0, we can definitely say that acceleration will be 0. Okay, so there will be no acceleration, and I can definitely say that the person will stand, remain standing. It won't go up, it won't go down, it won't slip along the surface. Is it clear? I hope that this thing is clear. Let's move to the another part. Now, as we all know that in this universe, there are only two things which exist. In this complete universe, there are only two things which exist. In this universe, there is a matter, there is energy. And you know that according to Einstein, there is a bridge between them. According to an Einstein, there is bridge between them, and that is E equals to E is equals to mc square. Right? So, do you know what is matter? Matter is basically anything that has mass and it occupies space. Anything that has mass and occupies space. But having a mass will not affect its velocity, acceleration. I would be saying the kinematics is not being affected by the mass. You have already seen that in the kinematics, right? Mass does not, we were not considering the mass when we were dealing with the kinematics. But Newton also concludes, or I would say that Newton also includes that the property of the matter gets changed when that matter is getting the velocity. Like, assume that I am having a ball here. This ball is being placed on the table or on my hand. Nothing has happened to my hand. But assume that this ball is coming from a particular height and it touches my hand. There is some change what I felt when it hits my hand, right? It hits with a particular velocity. Velocity, we know that velocity does not depend upon the mass. But when I multiply this mass with that particular velocity, then this body is carrying something else. And what is that something else? That is momentum. So momentum is basically the product of mass and velocity. Simply a product of mass and velocity. So it might happen that you may have a body which is having a very small mass but having a very, very high velocity, and it could create a very good impact, like a bullet. A small bullet is like will be of 20-30 gram. You will be providing the velocity to 500-600 meter per second, and if that bullet hits an animal or human, and it has the ability to kill that person. And if there is a truck with a very heavy mass, even the truck was moving with a very small velocity, it is basically carrying a momentum. So it's the momentum which we have to consider rather than only the mass or the velocity, right? So this is what Newton told to us. Now, okay, let's first do this thing. Newton's second law. Newton's second law. As I told you that we will be dealing all these Newton's laws, considering that we have to solve the numericals, right? I'll not be teaching you in a way so that you will be getting that your theory will be clear, but you won't be able to apply that in the numericals. I'll be teaching you in such a way that whenever you are seeing the question, you will be start seeing that yes, you have to apply this law. So according to Newton's second law, the first method which must be coming to your mind is that if acceleration is not equals to 0, earlier the acceleration was 0, right? When acceleration was 0, we were saying that force is equals to 0. I'm saying that if acceleration is not equals to 0, then there must be force, and that force is equals to mass into acceleration. Also, here, similarly, you could say that if F net is equals to not equals to 0, then acceleration will be equals to F net divided by m. Okay, this is the method 1. Another method, method 2. This is the method which we will be using like whenever we are getting very easy questions, we have to use this thing. That for us, Newton's laws is force is equals to mass into acceleration. But in reality, Newton's laws is equals to that external force. What is external force? It's the push and pull. So according to Newton's second law, the rate of change of momentum is directly proportional to the applied force. So I can say that the force is directly proportional to the rate of change of momentum. And if you replace this force with k dp by dt, consider this k as 0. Consider k is equals to 1. So force is equals to dp by dt. And you know what? This momentum is equals to the product of mass and velocity. So I can say that force is equals to differentiation of mass velocity dt. So first time leave mass, differentiate the velocity, it will be dv by dt. Then leave your v, differentiate dm by dt. So this is the real law. Force is equals to m dv by dt plus v dm by dt. Okay, so this is the second method. And according to this method, there might be two cases. Case 1, when mass is constant. When mass is constant, I can say that dm by dt is equals to 0. Okay, and you can write it as force is equals to m dv by dt is equals to ma. There might be case when velocity is constant. So when velocity is constant, force is equals to v dm by dt. Okay. Uppuswamy PKS, you are from Tamil Nadu, Kumbakanam. Okay, great. And please share this session with your friends. I hope that this Newton second law is clear to you. Let's solve some question. Is this thing clear to you? There are these two methods which you have to understand that we will be applying this method, right? Shall I show you something? Let's take an example. Consider there is a floor. On this floor, I'm having a block of mass 10 kg. A force of 50 Newton is acting on this. It's a 30-degree, or take 60-degree. Now you have to find out at what will be the acceleration of this block. Find the acceleration of now what will be your approach? Similar type of question was asked in JEE 2024. What must be your approach? Tell me. Wait, future IITN is saying, sir, please wait. Okay, do let me know that what is the acceleration. First and foremost, you know that the displacement will happen in this direction. And when this displacement is happen in this direction, you have to consider that force only. The only approach we will be using is that we would be dividing the whole scenario. We won't be seeing the picture, because when you are seeing the picture, the question seems to be very difficult. You always have to see the pixels. And what is the pixels here, or what is the pixels in physics? The pixel is, you have to see in terms of the x-axis, you have to see in terms of y-axis, or you have to see in terms of the inclined axis. Sometimes we have to take the inclined axis as well. So this is what you have to see. This is the rule of divide and rule. Now, when I am saying the pixels, you have to see in terms of x-axis, in terms of y-axis. So, according to this question, let me take here. What will be the force in this direction? This force will be F cos 60 degree, right? So this is 50. Cos 60 degree is 1 by 2. You can consider this as 25. So the Fx, that means the force in the x direction, is 25. The mass is 10 kg here. And due to the, you would be saying, sir, why you are not taking the force in y direction? Why I'm not taking the y direction? Because it's a horizontal surface, and if this is a horizontal surface, due to this force, this object won't move anywhere, right? So if due to this force this object is not moving anywhere, why would I take this force? I won't be taking that force. So the only force which is there, due to which this block is getting the acceleration, is the force in the x direction. Is it clear to you? Always see in terms of pixels. Do not go for the picture, because picture is always difficult. You have to see the pixels. Whenever you started to see questions in the pixels, that means you know that how to approach the question. So now here we know that Fx, the force in the x direction, is 25. The mass is this. So I know that force is equals to mass into acceleration. And when I have to calculate the acceleration, I can say that acceleration in the x-axis, my answer would be force in x direction, and the mass here. The force is 25 and the mass is 10. So it's 2.5 meter per second square. Is this thing clear to you? Please do let me know. Is this thing clear to you? Hari. Okay, Hari. Yes, I remember you. You were there in the last class as well. Now, let's let me assume that there is a pump, and due to this pump, a water is coming out with a velocity of 5 meter per second, and the rate of mass at which it's coming out is 3 kg per second. Mass of water which is coming through this pipe is 3 kg per second, and there is a floor, a frictionless floor out there, on which we have kept a block of mass 10 kg. Okay, and you need to find out the acceleration of this block. Find the acceleration of the block, right? So now tell me, there is a pipe through which a velocity which is coming out to be is 5 meter per second, and the mass rate is given to us as 3 kg per second. You have to find out that if this water is basically hitting this block and it's resting on a frictionless surface, what will be the acceleration of this block? So this is the question which is being asked. Now you have to solve the question. I already told you that you do not have to see the picture, you have to see the pixels. Now I am seeing here a different scenario, or we have been provided by dm by dt. That means the rate of mass is given here. So I could not get the acceleration as force is equals to mass into acceleration. So I have to use a different formulas. As I know that force is equals to dp by dt, and you know what? It's dmv by dt. It's m dv by dt plus v dm by dt, right? So you could write it as velocity is constant here. So when velocity is constant, I can write force is equals to v dm by dt. The force which is acting on this block, because we have to see that what is the force here. Force which is acting on this block is 5 into 3, 15 Newton. Mass is already given, so acceleration is equals to F divided by m, 15 divided by 10, so it's 1.5 meter per second square. Is it clear, my dear? Is it clear, my dear? Right, wait a minute. Is it clear? Chats are not there. Battery drains out. Is it clear? Let's move forward. And now see, you know what? Why we use bubble wrap or the China wrap whenever we are like importing or exporting any items, or I would say that we have to basically wrap every delicate items in bubble wrap or airbag. This is because we know that force is equals to dp by dt. If I'll increase the time, the force will be less. If time is more, force will be less. More time, less force. More time, less force. Imagine that you got an extra 1 year for your JEE preparation. What will happen? You won't be that much serious, right? If you have exam, like assume that if you are having an exam just after 10 days, you will become more serious. So it's the same thing. If we have less time, that's why I always tell to my student that whenever you are having a very less time, your focus increased a lot, and that's why you score more marks when you are studying for just for few days. Just if you want to clear the exam, you can do it by studying for 15 days or 20 days. But if you want to get a very good rank which you feel proud of, you have to work that continuously, consistently, at least for these 2 months. So when there is less time, then there will be more force. So actually what we are doing is to like to protect the delicate items, we are increasing the time. Similarly, same thing happens when there is a bike helmet. There are cushions being provided. So what does these cushions do? This increases the time of impact, and because of that, force decreases, right? Let's see. This is basically a concise map of the Newton's second law. It states that that if something is changing, force is there. If something is changing, force is there. And what is changing? If acceleration is not equals to 0, then force is there, and that force is equals to mass into acceleration, right? And this was the first point, and the second point is that force is equals to dmv by dt. You can write it as d dv by dt, m dv by dt, v dm by dt. So if you are slow, then force is less. If you are same, then force is 0. If you are moving very, very fast, if you are fast, then force is. And to remember this law, please remember this law as a law of injury, because this law is being used to avoid the injuries. We can increase or decrease the time. If we have to cut something, we have to do it instantly, right? And if we have to save something, we have to take some time. So this is what being there. This question is from JEE Main 2024, first Feb shift 2. So for the January attempt, this question is very, very important. You have to attempt this question. I'll be giving you a timer here to attempt this, and please let me know the answer in the chat. I want everyone to attempt this question. I want everyone to attempt this question. Just 1 minute is enough for this question. Let's solve this question together. Let's solve. Hurry, and please share with your friends. Please let me know. Clear? Rama Krishna Sai. Okay, great. Solve this question, Rama Krishna Sai. And please attend the complete lecture. Why you are like, you will watch this lecture later on. It will add on your backlog. Now, let's see. According to this question, we have to find out the acceleration acting on the body. And we know that acceleration is equals to F net, net force acting on the object, and the total mass of the object. So here we have two forces, F1 and F2. Here we are having two forces, F1 and F2. And like F1 is equals to 5 I cap plus 8 j cap plus 7 k cap, and F2 is equals to 3 I cap minus of 4 j cap minus of 3 k cap. And you know what? What is F net? F net is F1 plus F2. And doing addition in a vector format is very, very easy. You just need to add only the I cap with I cap, j cap with j cap, and k cap with k cap, right? So 5 plus 3 is equals to 8. So I can write this as 8 I cap plus 12 j cap plus 4 k cap. एट माइनस फोर है here, 8 minus 4 plus 4 j cap. Okay, this is done. So we are having this thing. Now we have to find out acceleration. So acceleration is equals to 8 I cap plus 4 j cap plus 4 k cap divided by mass. Mass is given to us as 4. So divided by 4, you will be getting acceleration in a vector format. So it will be 2 I cap plus j cap plus k cap. This is your answer. This is your answer. Is this thing clear? Let's move. Now, it's time to learn about the third law of motion. What does third law of motion says? Third law says that for every action, there is an equal and opposite reaction. This law seems to be very easy, but this is the toughest law, I would say. This is the toughest law in terms of the conceptual understanding, because I have seen many students facing issues while whenever I started asking the conceptual questions, they would be giving me the wrong answer. The statement is very easy, that for every action there is an equal and opposite reaction, and it is like F12 is equals to minus of F21. The force acting on the second body due to 1 will be equals to the force acting on the first body due to 2, right? But you know what? There are certain conditions. The first condition is that there are some certain condition. The first condition is that the action and reaction will never act on the same body. The first condition is that action and reaction never ever acts on the same body. Never acts on the same body. Action and reaction always acts on different body, right? The second thing is action is always equals to reaction. This is already written here, so I won't be writing that. The type of force for action will always be equals to the type of force of the reaction. So the first thing is action and reaction never acts on the body. The second one is that the type of force for action will always be equal to the type of force of the reaction. I have to explain this second equation. For before that, you must know that how many types of forces are there. According to previous books we were having, there are only 4 fundamental forces we have in nature. The first one is the gravitational force. It is because of the masses. So any object, or I would say it's better to say that any matter in this universe will be experiencing this gravitational force, because every matter on this earth is having the mass. Second thing is electromagnetic force. This force is due to the charges, due to the tensions we will be having. So many a time we will be dealing with these electromagnetic forces. The third and fourth is due to the nuclear force, and in those nuclear forces we have a very small distance. The distances will be in pico or femtometer. So this is not, we are not considering these forces now on. We will be dealing with these forces when we started our chapter nuclear. Okay. So these are basically 4 fundamental forces we have to study. Now, assume that we have a earth. This is the center of the earth. This is the radius of the earth. Okay. This is the mass of the earth. You know what? You know what? There will be a weight that is equals to mg. There will be a weight that will equals to mg acting on this person, and also you know that this person is not moving downward. If I'm telling you that this weight, if I'm telling you that this weight is, I'm considering this weight as an action, please let me know that where will be the reaction. If I'm telling you that on this body M there is action, an action is the weight force which is acting. Who is generating this action? Earth. From where? The center of the earth. So the reaction will happen at the center of the earth, reaction will be there at the center of the earth. Reaction will be at the center of the earth. Many a time students are confused that this normal is the reaction of this. This normal is not a reaction. This normal is not a reaction. Okay, so this you must remember that due to this weight, if I'm considering this weight as an action, the reaction will happen on the center of the earth. Now, Maruthi Edepu, hello. So tell about NIT Varangal home state quota for CSC, how many marks are required? Maruthi Edupu, the best way to get a knowledge about this thing is to go on JOSA website. So go to JOSA website and there you can like put the filters out there for the NIT Varangal, for the CSC branch, for the state quota. So if you put all those things and your basic category, the general, EWS, OBC, SC, ST, you will get the information that at what rank person is getting the NIT. What is the starting rank? What is the ending rank? Till the subsequent rounds are there. So you would get that thing, right? This is the only way to get the information, right? And please continue this lecture because this lecture will help you to get those scores which you really want. Now, moving forward, here we are having, this is already being done. I have put that everything on the first slide. Now, if we will consider the examples of third law, the third law best example is the rocket we are having. So in the rocket, the air gases creates the action. The air gases creates the action and we get the reaction seeing that the rocket is going upward. Similarly, when we are moving or when we are walking, when we are moving or when we are walking, we are applying a force, and due to this force, when we are applying force and due to this force, we move forward. Okay. Now, if I want to concise this Newton's third law, the third law states that if action is on you, the reaction will be on other. Sometimes people may confuse that if action and reaction are same, that why something is moving. Why something is moving? Because action and reaction don't act on the same body. This is what you have to remember, right? And you have to remember that this is basically a law of internal motivational or revamp. It means sometimes when you are in a doubt that whether you have to apply the third law, you have to apply the second law, you have to apply the first law, there are some examples which you have to keep in your mind, and in those examples you can see that why the first law is dominating, why the second law is dominating, why the third law is dominating, and according to that you could able to think when you got the assertion and reasoning questions, right? So now let's solve this question, but before solving this question we must know a free body diagram. How many of you know about the free body diagram? Because without free body diagram we won't be able to get what we want. Free body diagram. So free body diagram is basically the pictorial representation. I can say that it is basically a pictorial representation or a graphical representation, a pictorial representation of all the forces, acting on the body. Now, there are some common force which we have to consider and which we must know that how to use those forces. There are common forces, some common forces I would be better. Some common forces which are there in our JEE syllabus, and we would be seeing those forces when we are dealing with the numericals one by one. The first and foremost thing is the weight. You know what? What is actually a weight? A weight is basically tells us about that by how much force the planet is pulling us, right? This is basically telling us that by how much weight, by how much force the planet is pulling. Isn't it what you are saying, Maruti? Yeah, I'll create a separate video for that, Maruti. Don't be tense about that. That is my work. I already told my student that everyone's responsibility is no one's responsibility, but your responsibility is my responsibility when you comes to my life daily. Like Hari is coming to my classes daily, and I have already shared one Google Drive with you. In that Google Drive, you will be getting the highlighted NCRT, you will be getting my class notes, you will be getting the PPT, you will be getting the PDF which I am using here. You'll be getting all the links without going into the YouTube. So if you want to revise Newton's laws of motion, you can directly click on this link. You will be getting the practice paper there. So do follow us on Telegram. I have already shared that file with you. Okay. So Maruti, I'll be taking another separate session for that. Shall we move? So weight is basically the force by which planet, by which planet attracts the object. And you know what? Direction of force is always acting downward. Assuming that this is a horizontal surface, and we have kept an object of mass m, and you know what? The weight of the body is mg. Now assuming that, what if we are having an inclined object? If we have even when we are having an inclined object, the weight will be acting downward, mg. Okay. The inclination does not affect the direction of the weight. Similarly, even if you are having the ladder, then also you could say that the weight is acting downward. Assume that the mass of the assume that the mass of the ladder is m, then the weight we can use here is mg. Mg always acts downward. mg always acts downward, right? Similarly, we will be having the pulley numericals in that also, you could say. In that also, you could say m1, m2. The weight here is m1g, weight here is m2g, right? So weight always acts downward. Weight always acts downward. This you must have to keep that thing in your mind here also. Now, let's assume that we are having horizontal object here. Now, the weight here is m1g, weight here is m2g. Okay. So these are basically the weights direction. So whenever you are drawing the free body diagram, you have to do this. Maruthi Adapu. I have already shared. See, there is a pin chat by Rankplus JEE English. Join Telegram for notes and latest updates. So you have to click on this link and join our Telegram group. And when you join our Telegram group, you will see there I have shared a document out there. In those documents, you will be getting all the links of my classes, all the PDFs there, all the assignments, notes I'll be uploading there. Okay. You just need that link for the physics. Is it clear, my dear? Now, let's move towards the next force, which is common reaction or normal force. So normal force is basically a perpendicular force. This is basically a perpendicular force at the point of contact. Perpendicular force at the point of contact. Okay, let's consider an horizontal surface. On this horizontal surface, if we kept a block M, block of mass M, the force acting on this block is mg. And when this block is basically touching this surface, due to this surface, there will be another force, a normal force. And if this object is not moving anywhere, I could say that this normal is equals to mg. Okay. Similarly, at any point, whenever we see that an object is touching, you could draw the normal force, assuming that if we are having an inclined surface, of mass m, weight mg is acting downward, normal force will act here. Okay, is this thing clear? Normal will always be perpendicular to the point of contact. And the third thing which you have to consider is the tension force. Tension force we have to take in two things. First, second. Tension force we have to take in two things. First and second. The first one is due to rope, and due to rod. Due to rope and due to rod. Due to rope, there will be only pulling force. Due to rope, only pulling force. And due to rod, there could be a push or a pull. But mainly we'll be dealing with the massless rope. So the conditions for idle rope which we have to take when we are solving the numericals. Condition for idle rope is that rope is massless, and second one is, the first one is that the rope is massless, and the second one is inextensible. Plus friction is also not there. We won't be considering the friction. Okay, so now let's see. If I am having a surface, on this surface we are having a block M, block of mass M, and we are pulling this. If we pull this by force F, we are basically applying the force F. And you know what? If my point of observation is this person, then this block is also applying some force but in the opposite direction, and this is actually the tension generated in the string. But if my point of, if this block is important for me, if I'm considering this block, then what will happen? Let me take a different pen. Then according to this, the tension direction is in this, and due to this tension, this block might experience some acceleration. So you know what? Tension is always acting away from the body. If I'm considering this person, the tension is acting away. If I'm considering this block, if this block is important for me, the tension is acting away from this block. Okay, so tension in an idle rope will always act in the opposite direction. Similarly, here you could take This is M1, this is M2. Now consider that due to weight, the weight is acting downward, the tension will act upward. The weight is acting downward, the tension will act upward, right? So this is what we have to do in case of tension. I hope that this thing is clear. You have mastered the laws of motion. Oh, great. Great to know that you have mastered the laws of motion. So I hope that this thing is clear to you, right? So let's move here and solve some questions, solve some numericals. Here in this, you are seeing that a heavy particle and the particle mass is given to us. The mass is 0.5 kg, is hanging from the string fixed with the roof. Find the force exerted by, you have to find the force exerted by the string on the particle. Okay, so basically we know that due to the mass, there will be weight, and that weight is equals to 0.5, and we have to take here 4.9. So it comes out to be 4.9 Newton. And you know what, if there is a string and this object is not going anywhere, what does it mean? It means that the tension due to this string will be equal to the weight of the body. So I can clearly say that the tension here, or the force exerted by the string, the tension is basically the force exerted by the string is equals to mg, and that is equals to 4.9 Newton. Okay, now let's move. Now it's the time to know another very important concept, the concept of impulse. So impulse is basically acts on the body when the force is very large but the time of duration is very small. So we know that force is equals to the rate of change of momentum, dp by dt. And if I'll get the dp here, I'll get dp as f dot dt. It's not the desktop picture you are having, or dp. So this dp is actually an impulse. There is a large force acting for a very short duration. Okay, so this is what we are having in an impulse. Let's solve some question related to the impulse. Here we are having a question. According to this question, a batsman hits back a ball straight in the direction of the bowler without changing the initial speed of 12 meter per second. If the mass of the ball is this much, determine the impulse imparted to the ball. So you know what, how to play cricket. So imagine there is a cricket pitch and we have the batsman. Please do let me know that who is your favorite cricketer and your favorite cricket team in the IPL. Here we are having a batsman. This batsman is actually hitting an object or a ball. A ball is coming with a direction with v velocity, and once he hit, the ball will go back with another with the same velocity v without changing. Let direction is changed. The mass is 0.15 kg. Impulse you have to find out. Impulse is delta p. Delta p is what? P final minus p initial. Here you have to consider the direction of the velocity, one as positive, the another one is negative, and I am a kind of a person who goes with the flow. I'm a kind of a person who goes with the flow. What is the flow? Flow is, you know what, we are having a Cartesian plane. In the Cartesian plane, we are having a there is a positive direction, there is a negative direction, there is a positive direction, there is a negative direction, right? So I'm assuming that if I'm drawing this diagram like this, then what will happen? I'm a kind of a person, I already told you, that go with the flow. And what is our flow? Flow is use the Cartesian plane. The velocity of the object which is going in this direction, I'll consider this velocity as negative. So I'll consider initial velocity u as minus v and the final velocity as plus v, because this velocity, the final velocity is going in the this direction, the positive direction. So pf is equals to mv minus of mv. So I'll be getting I impulse is equals to twice of mv. So now if you have to find out impulse, that will result into 2 mv, put the values. 2 into mass is 0.15 and velocity as 12. Three point 6 kg meter per second. Okay. Lord Hari, are you there, Hari? Hari, are you there? No? Let's move. 'Imagine that there is a wall, okay, and a ball is coming from the ball mass is m. This is basically a theta. This is going with v1 velocity, and again after hitting this point, the ball is going with v2 velocity. Okay. So this object is going in this direction, and after hitting this object is going in this direction. This is the angle theta which is being given to you. You know what? You have to believe in me. You have to believe that if Manoj Sir is teaching us, Manoj Sir will teach all the patterns which is important in the exam and which might get into the exam. So I have already told you that how to find out the impulse, how to get the change in the change in momentum. So here, if I need to find out the initial momentum, I'll be saying this is P. I'm considering this as initial momentum. This initial momentum, I always take the momentum in the perpendicular direction. So if this is the velocity v1, I would be considering this velocity. This velocity is v1 cos theta. So my initial momentum is m v1 cos theta and this is going in this direction. You can take this v2 cos theta, final momentum. Okay. Now, if I'm talking about delta P, which is PF minus of PI, it is equals to, okay. Now again, there is one velocity which we have to take positive and another velocity which we have to take negative. I always goes with the flow, and the flow says that to use the Cartesian plane we are having. So this direction will be considered as positive and this direction will be considered as negative. This as positive, this as negative. So you know what? If this object is going in this direction, I'll be considering this as positive. If this is going in this direction, I'll be taking this as negative. So now the final momentum is minus mv2 cos theta minus mv1 cos theta. Okay. So this is what we will get. And you know what? There could be some condition for the special case. For the special case, now you tell me that what could be the special case. Special case is like v1 is equals to v2. So in this special case, it might happen that v1 equals to v2, and when v1 equals to v2, delta p will be equals to minus of 2 mv cos theta. Okay, now let's move forward. This is a question for all of you. This question is being asked in JEE Main 2024. Now see how we are going to approach this question. This is basically a constrained motion type numerical. In the constrained motion numerical, what we have to do is, the first step what we have to do is to get the acceleration of the system. Here, if I'm like seeing this object, then what will happen? If I'm applying a force F here, this block, C block, B block, and A block all will have the same acceleration, right? If I'm pulling this system, then what will happen? The block A, block B, and block C will have the same acceleration. Will you agree with me? Have you played this type of game? Sir, electrostatics next, please. Ragul, please come in live class. Then I'll take the topics as per your suggestions. Rotational motion, also I'll take the rotational motion, electrostatic. These are the topics which considered to be high weightage topics. But laws of motion, you must remember that these are the fundamentals. That's why I'm first going with the fundamentals. The electrostatic will come later. And I have completed the gravitational chapter. You know what? Gravitation is basically the fundamental block of the electrostatic chapter, because you will see the same concept, similar type of concept you have to deal with in the electrostatic chapter, what you have learned in the gravitational chapter. Shall we go with the question now? Let's see the question. In this question, there are three blocks A, B, C, and that are being pulled by a force of 80 Newton. You have to find out the tension. What I'm telling you, that you have to I'm telling you the easiest method. The easiest method is whenever you are seeing the constraint type motion, the first step what you have to do is getting the acceleration. The first step in these types of question is find the first step is find common acceleration. Find common acceleration. Acceleration is equals to the force which is being provided there and the total mass we are having. So force is equals to F net divided by M total, and the force which we are having here is 80. The total mass is 5 plus 3 8, 8 plus 2 10, 10 kg. You'll be getting 8 meter per second square. So acceleration is 8 meter per second square, and now we have to find out T1 and T2. The easiest way is to get started with the block which is independent of the other block, or I would say that which is the last block. So here the last block is A block. So for block A, the acceleration is 8 meter per second square and the tension here is MA. So tension here is 5 into 8 and you will be getting a 40 Newton tension. You'll be getting a 40 Newton tension. And only by getting this, you can mark the correct answer. Only getting this, you can mark the correct answer. This question is from JEE Main 2024. And you know what? If I have to calculate the tension 2 here, which is there, what I'll be doing, I'll be considering this block A and B as one block. I'll be considering this A and B as a system. And if this being a system, I can consider that a 8 kg block is being attached and we are pulling with this string T2. So for block or I would be saying for T2, for getting tension T2, what we have to do is I'm considering this as a system, and if this is if I'm considering this as a system, then what will happen? The total mass will be 8 kg. The total mass will be 8 kg, and acceleration will be 8 meter per second square. The tension T2 will be 8 into 8. We are having 64 Newton. Okay, I hope that you got the correct answer. Raghul, Hari, Maruti, future IITN, Hari. Is it clear, my dear? Now let's move. Okay. Before moving forward, we have to know an important pattern, the pattern of the questions which we might get in our exam, the pulley numericals. You know what? What is the pulley? Pulley is basically a simple machine. Pulley pulley. So I'll show you that what is pulley. This pulley. These two things will work. You might have seen this at any construction site. This is pulley. And you know what? What does pulley do? It changes the direction of force. Second thing, changes the magnitude of force. Magnitude changes only when there are multiple pulleys. Uh, it won't be changed when we are having only a single pulley. Okay. And like this is a simple machine we are having. We use it to change the direction. We used it to change the magnitude. We will start with the very prime concept, which is a single pulley. See, pulley can also be a single. Are you all single? Let's start with single pulley numerical. Single pulley. Weight M1G acts on this, there will be a tension. Weight M2G acts on this, there will be a tension. Okay. And I would consider that mass 1 is greater than as compared to mass 2. So what will happen? This mass 1 will goes down, this mass 2 will goes up. Right? If this is moving, this moves by x distance, then this object will also moves by x distance. First and the foremost thing you must know here is that how to apply Newton's law. You know what? If there is a tug of war, in a tug of war, there are two opponents. First one is Rocky. The another one is Pushpa. They are, this is a separation. As Pushpa movie is going to release, as Pushpa movie is going to release, I'll be telling you that this force is more, and this tug of war is like this rope is getting accelerated toward this Rocky bhai is also applying a force, but in the opposite direction. But as Pushpa is more stronger than the Rocky bhai, then what will happen? The like Pushpa will pull it by a very large force, and the acceleration will be in the direction of Pushpa. And you know what? If I need to find out that what is the net force acting on this, the net force will be equal to the force exerted by the Pushpa minus the force exerted by the Rocky bhai. So the F net here will be F1 minus of F2. Are you all clear with this? This is the F net in a tug of war. Similarly, here, if this is just an example, I'm keeping this example here. I'm telling you that for block M1, for block M1, you have to consider for this block, this M1G is acting downward. So consider this M1G minus there is a tension force T is equals to F net is equals to mass into acceleration. We are basically using this Newton's second law. So it states that F net is equals to mass into acceleration. So as I told you that this object is going in the downward direction with an acceleration a, then what will happen? This is being there is a force m1g here. So m1g minus of tension is equals to m1a. Then if you find out the tension will be m1g minus of a. And I always wanted you to please make this, you should know that how to create the equation for the block, for the next block, for the M2 block. We will be doing something different because this block is going in the upward direction. For block M2, I can say F net is equals to mass into acceleration. F net is T minus M2G. Is equals to M2A. Then this T is equals to M2. T plus A. Okay. Now this thing is clear for block M1 and block M2. And we know what? For one rope, there is one tension. For one rope, there is one tension. I can compare this equation 1 and equation 2. M1G minus of M1A is equals to M2G plus M2A. And if take this side, M1 minus M2G divided by M1 plus M2, you'll be getting this. This is actually a way to solve this question. But you know what? How we are going to solve this question in the exam? if we start to doing like this, then what will happen? It consumes a lot of time. And time is the real asset what we are having in the exam. So I'll be using a shortcut trick for this. What is the shortcut trick? Generally we have to find out only two things. The first one is the acceleration and the second one is the tension here. So for the acceleration, for the acceleration is equals to unbalanced load divided by total mass. Unbalanced load divided by total mass. So unbalanced load is, this is m1 minus of m2, because m1 is more force, m1 mass is more as compared to m2. m1 minus m2 divided by m1 plus m2. Okay, so this is the acceleration we are having. And for the tension part, there are three scenarios. An object can be at rest, object can move upward, object can goes downward. Okay, so if there is a m mass here, m mass here, m mass here, the weight here is mg. If it is going with an acceleration a, if this block is going with an acceleration a in the downward direction, then weight will be equals to mg minus a. For a free fall object, the weight will be 0. When acceleration is equals to g, the weight will be 0. Whenever you are going down, you are not taking any tension. Similarly, here, if something is moving upward with an acceleration a, the weight is equals to mg plus a. Now, similar to this line, there is another pattern. Assuming that there is a rope, and on this rope there is a person of mass m. This person is at rest. The weight is acting downward, mg. The tension force is acting on the upward direction. The T is equals to mg. Here in the downward direction. The mass is m. The weight is acting downward. Tension is acting upward. The acceleration is in the downward direction. The tension is mg minus a. What does it shows? It shows that If you want to stay at one location, if you want to stay at one location, your tension is at a particular value. If you are going in the downward direction, then you are decreasing the tension, right? So when the tension is decreasing, it is going in the downward direction. But similarly, if I'm telling you that if an object is moving in the upward direction, mass is mg. When you are going in the upward direction with an acceleration a, then tension is equals to mg plus a. And remember this thing, that we are considering this as a reference. When the object is at rest, we are considering this as a reference, and this weight is equals to mg. If we are going in the downward direction, then the weight will be reduced, mg minus a, the tension will be reduced. If we are going in the upward direction, then the weight will increase, or you can say the tension will also be increased. So this is how we are going to do. And you know what, there is like different patterns, or I would say the variety, single pulley variety, which you might see. M1, M2, M3 is there. Here, I'm saying that we are having an acceleration A. This M3 is going in the upward direction. If you have to find out the acceleration, acceleration is unbalanced load divided by total mass. Unbalanced load divided by total mass. So unbalanced load is M1 plus M2 minus of M3 multiply by it by G. Load is M1 plus M2 plus M3. For the tension, there are two types of tension. The first tension, here also, tension is the first part. This is tension T1, this is tension T2. These tensions are same because rope is same. So for tension T1, I can write, because this is being attached with this M2. So you could say it's M2 T minus A because it's going downward. And for T2, it's G plus A. Is it clear, my dear? So this is how we are going to solve these types of questions. Similarly, here, if we are having a horizontal block, on this horizontal block, if I am having a mass M, For this, if I need to find out the acceleration, acceleration is equals to unbalanced load divided by total mass. Unbalanced load will be equals to, what is the unbalanced load here? You know what, this is being kept on a horizontal surface, so this is balanced by this horizontal surface. This m2 is being balanced. Only unbalanced force is m1 here, so I can write m1g divided by m1 plus m2. If I need to find out the acceleration could easily be find out using this m2. So tension is equals to m2a, and similarly tension can be find out using this m1. This is m1g minus a, because this block is going in the downward direction. So this pattern is also very, very important. And other than this pattern, you'll be seeing an inclined plane pattern. This is m1, this is m2. We have theta here. The weight is mg. Here it's mg sine theta. Okay, so if you have to find out, the acceleration, you can take the acceleration as m1 minus of m2 sine theta divided by m plus m2. And if there is alpha and beta out there, for tension you need to frame the equation. Tension here could be easily find out, but here we have to frame the equation using the second law of motion. So I'm considering a block m1 here, I'm considering a block m2 here. There will be a force m1g sine theta, 1g sine beta, and here it will be m2 sine alpha. And if you need to find out the acceleration, I'm considering m1 as more. So you can do one thing, m1 sine beta minus m1 m2. This you will get. Okay, so this is basically the pattern we will be following for the single pulley variety. And there could be question being asked in JEE exams where you will find multiple pulleys. In multiple pulleys, the first thing what you have to do is to assume the acceleration Okay, and if you do that thing, then you can go further. This is two pulley. Here we are having two pulley. Then we can go for the multiple pulley. Multiple pulley questions you will only be getting in the JEE Advanced. You won't be getting in JEE Main. So you have to remember this thing. Sai Sharan, welcome Sai. From where are you from, Sai? And how are you? And tell me the toughest topic in physics which you feel that this is the toughest topic. I'll take a complete lecture on the toughest topic and I'll make that toughest topic easy for you. So in this case, first thing what you have to do is the first step, which will be a golden step. First step is assume acceleration. First step is assume acceleration. Okay. Now, consider if this object is being down by x distance, this object is being down by x object, then by how much this object will move forward? Tell me. If this object is like if I'm pulling this object by an x distance, then by how much distance this object will move? This object will move by x by 2. Why? Because to get this here at a distance x, I require x by 2 row from here and x by 2 row from here, right? So because it's all about the rope is inextensible, so I'm thinking in terms of rope. You also have to think in terms of rope. So if I'm extending this object by a distance x, then how it could be possible? It could only be possible if I'm like getting a rope x from this side. And to get a rope x from this side, I'll be assuming that x by 2 rope will come from this side and x by 2 rope will come from this side. Then only this object will move by x by 2. So if the velocity of this object is v, the velocity of this object is v by 2. And the acceleration is a, then the acceleration is a by 2. But for making the calculation simple, what I will do is I'll assume that I'll draw this diagram here just to ensure that how we are taking the forces here. Here I'm taking 4 kg. This is SA. This is 5 kg. So I'm telling you that you can consider that this object is having an acceleration of a or 2a. We will consider that this is having an acceleration 2a, this is having an acceleration a. Now, the first step is done. We have assumed the acceleration. Then for the next step, we have to frame the equation using the first step is this. Second step is to frame the equation. Frame the equation according to second law of motion. Now for this object, there is a weight mg, there will be a tension, and the acceleration is here. So I can write this as 4g minus of t is equals to 8a. Right? For this thing, you can write 2t minus 5g is equals to 5a. These are the two equations which we are getting, and solving these equation you will get the answer. These are the equation which we are getting. We have to, and when you, if you solve the equation, you will get the answer. So to solve this, I can do one thing. I can put t is equals to 4g minus 8a to this equation. G by 7. So a is equals to g by 7 we are getting. So acceleration of b is g by 7. So basically we have to find out acceleration of a. Acceleration of a is g by 7 and acceleration of b is 2g by 7. Oh, opposite. Acceleration of b is a, so it's g by 7, and acceleration of a is 2g by 7. So this is how we are going to solve this question. Okay. Similarly, you have the other questions of from HC Verma. I want you all to attempt this question. This question is from JEE 2021. So try to attempt those questions. I'm putting all those questions in this PDF. If you face any issues, you can comment below to get the correct solutions, or I'll take another sessions on the practice sessions for JEE main previous year. So I'm keeping all the questions in this PDF. To get this PDF, you have to follow us on Telegram. If you are not following, that means you are making a mistake, because for every topic which I'm covering, I'm putting that in one document, and all the PDFs you will get there, all the notes you will get there, all the practice sheets you will get there, and even the handwritten notes you'll get there, the digitally handwritten notes in which I have covered each and everything. So first thing you have to do is join our Telegram. Join our Telegram. The link is in the description. If you haven't, then please do it now, because this is the power of now. When you are doing it, you will see the result, right? And the next thing is attempt JEE PYQs of the years which I am telling you. First one is 2017, 2018, 2020, and another is 2023, 2004. Newton's laws of motion. To attempt these 5 years numericals. These are very, very important numericals. And so what is the next chapter? I'll take work, energy and power, because this laws of motion and work, energy, power is interconnected, and you will see that in work, energy, power, We will be applying the concepts of kinematics, we will be applying the concepts of Newton's laws of motion, and there you will be getting the approach, correct approach, that how to approach the numericals. Because I have seen multiple students, they do not face issues while doing the calculation, they face issues when starting the question. And I am like, this is my X factor, that none of my students face this kind of issue to initiate the question. They, like, they are the one who start the question just by seeing the question, that this must be the pattern. So this confidence I want to give it to you. So please subscribe our channel if you haven't, and do let me know in the comment section that which chapter you want me to take next. I'll take that thing in the next section. Okay. So bye bye. We will meet again.